Okay, so this preview today is all about something called atomic structure. So let's start off with what the word atom means. So already you've learnt about a term called a particle. Well, a particle is just a general term, and one of the particles that we can talk about is called an atom. Now, the word atom comes from ancient Greek, and this is when a Democritus, who was a philosopher in ancient Greek, he came up with, or in ancient Greek there was a word atomus, and atomus meant undivided. So what we're saying is an atom is a particle that cannot be divided. So every element in the periodic table consists of its own atom. So we're going to use the atom of helium as an example. And if we look at the periodic table, helium has the chemical symbol H lowercase e. It also has an atomic number of 2 and a mass number of 4. So, question now is, what does an atom contain? It contains 3 things, which you should know from year 9. It contains electrons, protons, and neutrons. And this should be not new to you. So, if I was to draw, so how it looks, there's going to be a nucleus. The nucleus is the centre of the atom. So, in the centre of the atom, we're going to have a total of 4 subatomic particles. The electrons, protons, and neutrons are subatomic particles because they are smaller than an atom. Subatomic means smaller than an atom. So we're going to have 2 protons, 2 neutrons, and then on the outside, in a shell, we're going to have 2 electrons. And then there's lots of space all between here. Loads and loads of space. So, the ones on an electron shell on the outside of the atom are called electrons. They are negatively charged. We are also going to have some positively charged subatomic particles. They are called protons. And we are going to have some neutrons. The easy way to remember this is protons have a positive charge, neutrons are neutral, so they have 0 charge, and electrons have a negative charge. We can also say that protons and neutrons are what we call nucleons. Now, nucleons that start well, that's all to do with the nucleus. Protons and neutrons are nucleons because they are found in the nucleus. And this number here is called the nucleon number. That is the number of protons and neutrons in the nucleus. So the nucleon number is the number of subatomic particles in the nucleus. For helium, this atom of helium, it is 4, therefore there are 4 subatomic particles in the nucleus. 2, which you would have heard as the atomic number, can also be called the proton number. The proton number means the number of protons inside the nucleus. The proton number here is 2 for this atom of helium. Therefore, the number of protons in this helium atom is 2, and that's the same there. So, just to move on slightly, there is something else you need to know about subatomic particles. So, we're going to look at the subatomic particles, and we're going to look at what is called the relative mass and relative charge. So, no units to each because they are relative. So, we've got our 3. Let's start with a neutron, proton, and electron. Okay, so the relative mass of a neutron is 1. It's that small to measure it in grams that we just give it this relative. We're saying, okay, so if a neutron is 1, we can also say that a proton relatively has the same mass. So both of them have the same mass, and it's easy for us to say, okay, relative mass of a proton and a neutron is 1. Well, for an electron, the electrons are much smaller. They are 1,834 times smaller, and it's really important that you know this value. It's not 0. You could say it's negligible, but the actual value is 1 over 1834. And then the relative charges. Well, we said that neutrons are neutral, so they have a charge 0. Protons are positive, so they will have a relative charge compared to a neutron of +1. And electrons have a relative charge compared to neutrons -1. So that's all of the information you need to know about the subatomic particles. But now, what you need to be able to do is you actually need to be able to look at an atom and say, well, what's the proton number, what's the nucleon number, what's the number of protons, what's the number of neutrons, what's the number of electrons. And I'll show you that now quickly. So, for example, for element He, we know from looking at this before, the 4 is going to be our nucleon number, and the 2 is going to be our proton number. The nucleon number will always be the largest number. So, our proton number is 2, our nucleon number is 4. So, the proton number is the number of protons in the nucleus. So therefore the number of protons in helium is 2. If the nucleon number is 4, and we know that 2 of the protons, which are nucleons, 2 of the nucleons are protons, therefore the number of protons and neutrons must equal the nucleon number. So that would be 2. Also, if you look here, in an atom, the number of electrons are always equal to the number of protons. So if we have 2 protons in an atom, then the number of electrons will also be 2. Let's do another example. So if I've got carbon, carbon's proton number is 6, carbon's nucleon number is 12. Therefore, if its proton number is 6, the number of protons in the nucleus is equal to 6. We need to have the same number of protons and electrons in an atom. So that would be 6. But also, if 6 of the nucleons are protons, that means if we do 12 minus 6, we are left with 6 neutrons. One more. Let's do this. 31, 15. Okay, now our proton number is 15. Our nucleon number is 31. Again, proton number, the number of protons in the nucleus therefore will be 15. The number of electrons must equal the number of protons, so that is 15. The number of nucleons that are protons is 15, so we need to do 31 minus 15 equals 16. Okay, final one. So if we do this is 39, 19. So we know that the proton number is 19, the nucleon number is 39. What are the values for the number of protons, neutrons, and electrons? Okay, and now look at these two examples. What's the nucleon number and proton number of each of these? Also, which element in the periodic table is each of these?